Terraforming Mars is not impossible. A new study describes the first step. This is by Andy Thomaswick from University Today. Terraforming Mars has been the long-term dream of colonization enthusiasts for decades, but when you start to grapple with the actual physics of what would be necessary to do so, the effort seems further and further out of reach. Depictions like those of Kim Stanley Robinson's Mars trilogy are just wildly unrealistic regarding the sheer amount of material that must be moved to the red planet to achieve anything remotely resembling Earth-like conditions, and that is the conclusion of an abstract presented at the 56th Lunar and Planetary Science Conference by Leszek Czechowski of the Polish Academy of Science. The paper, titled Energy Problems of Terraforming Mars, tackles the reality of what it would take in terms of gas to bring Mars up to an acceptable level of pressure. As Dr. Czechowski points out, water inside a person's body would begin boiling immediately at the current pressure on Mars, meaning that everyone on the entire planet would have to wear a pressure suit. However, certain places on the planet are closer to getting to the pressure level, estimated at about 1/10 of Earth's atmospheric pressure, where water would only boil at 50 degrees Celsius, which is slightly above typical body temperature. You got to start somewhere at least. And the place closest to that pressure currently on Mars is the Hellas Planitia Mars lowland, where the average pressure is about 1/100th of the sea level on Earth, and only 1/10 the amount needed to ensure a person does not immediately boil to death if their skin is exposed to the atmosphere. While Dr. Czechowski mentions several other scenarios, such as bringing the average atmospheric pressure on the planet up to that of sea level on Earth, the total amount of atmosphere that would need to be shipped in is an order of magnitude more, which already is extremely expensive in terms of energy required to realize that increase. And where would we get all this material for the atmosphere for Mars? Why, the Kuiper Belt, of course, or at least that is Dr. Czechowski's conclusion. He looked at the possibility of using asteroids from the main belt, which has the advantage of being reversely close to Mars, relatively close to Mars, but they lack enough water and nitrogen to help build an Earth-like atmosphere. The Oort cloud, the giant, at this point theoretical, the disk that contains billions of icy bodies, has more than enough material to supply Mars' atmosphere. However, after some brief calculations, Dr. Czechowski realized it would take 15,000 years to get a reasonably sized Oort cloud object near enough to Mars to make a material impact on its atmosphere. Impact is the optimal word, as well as the model these calculations describe slams the small body into Mars itself, thereby releasing both its material and a large enough amount of energy that would help warm the planet. Kuiper Belt objects seem best fit for this, as they contain a lot of water and could theoretically be brought to Mars over decades rather than millennia. However, they are also very unpredictable when brought close to the Sun. They could fall apart, with some of the material going to waste in the inner solar system, especially if the technique used to send them into the inner solar system involves a gravity assist. Such a maneuver could tear apart these relatively loosely held together balls of ice and rock. Dr. Czechowski's final conclusion is simple. At least in theory, we can get enough material to dramatically increase Mars's atmospheric pressure to a point where it's tolerable for humans, or at least to a point where they don't die immediately when exposed to it. However, doing so will require us to crash a sizable icy object from the Kuiper Belt into it. To do that, engineers would need to design a propulsion system that does not rely on gravity to direct the icy body. And in conclusion of his paper, Dr. Czechowski suggests a fusion reactor powering an ion engine, but does not provide any details about what that system would look like. There might be other methods as well to terraform Mars that involve bioengineering, but they would still take an absurd amount of energy, as Fraser discusses. And given the technological requirements needed to achieve that vision, it seems we are a long way off from doing so. But that won't stop Mars enthusiasts from dreaming of terraforming future, even if it does involve smacking the planet with multiple large rocks to get there. And this was originally published on Universe Today by Andy Thomaswick on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.